Okay, we are going to get into lesson 3, and this is all about the cross product. So this can have lots of applications in physics, engineering, geometry, where you're trying to find a vector in space that's orthogonal to two given vectors. Basically, you're trying to figure out how to meet this point in space at a 90-degree angle. So we call it the cross product, and it's kind of defined using this form where we have our vector u and our vector v be vectors in space, and then the cross product of u and v is the vector. So again, this is why we didn't use an x when we did the dot product, even though we were kind of multiplying, because the x signifies cross product. So again, dot product versus cross product are different ideas. So this only applies to three-dimensional vectors. The cross product does not work for two-dimensional vectors. And so a convenient way to kind of calculate this is to set it up in a kind of vertical fashion like this. This is used to help us remember the formula. It's kind of like a trick or a strategy to get the answers. So again, it's supposed to help us where if we look down here, so again, we're taking U2, V2, U3, and V3 right here, and then we're matching it with I. And then we're taking U1, V1, oops, I can't really see, this is about the same color. So then we're taking these ones and going with J. So you can again see, hey, if we're using the column of J, we have to use the numbers from I and K in order to make this idea work. And then kind of the same with K. Again, that's the third column, so we can't use K. We can only use these three, or these four numbers that are in the columns I and J to help us calculate. And then again, note the minus in front of the J. So again, that's right here. That each of these three 2x2 determinants can be evaluated by using the following pattern, okay? So this is how we will determine that we can calculate these like matrix type of equations. So you're basically, again, cross product. You're going across, you're going at the diagonal to determine what it is. So let's do an example. Let's say that U equals I plus 2J plus K, and V equals 3I plus J plus 2K. Find each cross product. And so the different examples that we're going to do for sure at least one. A is U cross V. So let's do that one first. So again, I'm just going to set up my column. I'm just going to set up my information. I'm going to have a column of I, a column of J, and a column of K. So again, I'm going to do something like this. Now my coefficients are 1, 2, and 1 for U. So I'm going to put my U column right here. I'm going to go 1, 2, 1. And then my coefficients for V are 3, 1, and 2. So for V, I'm going to say 3, 1, 2. Now I'm going to set up my cross product. So again, that's like what we were looking at right here above, where we have to match them up. So if I'm looking at column I, I know that I'm going to be using J and K. So I'm going to say, I'm going to set it up. I'm going to be looking at these four. So it's going to equal 2, 1, 1, 2, and that's I. Again, make sure you use a minus here. The first term is minus. And then for J, I'm going to use the columns I and K. So I have 1, 1, 3, 2 for J. And then my second term, I add. Or in between my second and my third, I have to add. And then if I look at K, I know I'm going to use 1, 2, 3, and 1 for K. So now we do this step right here where we multiply at the diagonal. So if I do that, again, this is going to give me 4 minus 1I minus 2 minus 3J. Again, what am I doing? I am cross multiplying. And then the last term is going to be plus 1 minus 6K. So when we simplify, we get an answer of 3I plus J minus 5K. that we want to switch it around. Let's say we want to do V cross U, right? I'm going to have, in this time, I'm going to have to set it up, again, I, J, K. It's going to be almost reverse, so it's going to be 3, 1, 2, and 1, 2, 1. So as we move to multiply or set it up, we follow our formula, and I'm going to say, all right, if I want to use I got to use columns J and K. So that's going to be 1, 2, 2, 1, minus, if I want to do column J, I got to use columns I and K, 3, 2, 1, 1, plus, again, notice the first one's minus, the second one's plus, 3, 1, 1, 2 for K. Simplifying, 1 minus 4I minus 3 minus 2 J plus 6 minus 1 K. So we get negative 3I minus J plus 5K. It's the weirdest J ever. So if I look at my two answers when I switched between U times V or U cross V or V cross U, I actually have, if we look at my signs, the inverse, okay? When this one's positive, this one's negative. When this one's positive, this one's negative. When this one's negative, this one's positive. All right, one more example. This one we can do relatively fast. Okay, we're going to take V cross V, set it up, I, J, K, 3, 1, 2, 3, 1, 2. When you go through and do all this, again, you're going to get multiplied 6 minus 6, 2 minus 2, 4 minus 4. So when you take the cross of something that's the same, V over V cross V, it's just going to equal 0. So this is kind of what we were, some of the stuff we were leading up to. We proved this one with our first two examples, is that when you switch it, you just have to flip-flop your signs. That was example A and example B. This was that third example that we just talked about. When you take two and you cross them, you're going to get 0. And again, some other ones that you will be exposed to and get practice time to look at as well. So those are algebraic properties. There are also geometric properties. So again, the beauty of this cross product idea is that it creates an orthogonal angle. It's going to meet at 90 degrees. The magnitude U cross V, the magnitude of U multiplied by the magnitude of V multiplied by sine theta. So again, we just said, hey, that equals 0 if they're scalar multiples of each other, and then the area of a parallelogram. So we will do some area stuff coming up here. Find a unit vector that is orthogonal to both. U equals 3I minus 4J plus K, and V equals negative 3I plus 6J. So I'm going to set up my cross product. I gotta do a better job. This is a U and the other one's a V. U cross V. So we have I, J, K. U comes first, 3. Looking at my coefficients, negative 4 and 1, negative 3, 6, 0. So when I go through my cross product technique, which again we did 3 examples up here, I'm going to fast forward. So when you go through that, you're going to get an answer that is equal to negative 6I minus 3J plus 6K. And so if we were to do the next step, which is to find the magnitude of U cross V. again, to find the magnitude, you have to use the square root of each of the terms. So 6, negative 6 squared plus negative 3 squared plus 6 squared equals the square root of 81, which equals 9. Therefore, a unit vector orthogonal to both u and v, which again, what did we do? We took the cross product of u times v, and when we looked at the magnitude of the cross product, we ended up getting negative 6i minus 3j plus 6k over 9. Again, this answer and this answer, top and bottom. And then again, what we can do is we can factor this out, simplify it slightly, and get negative 2/3 I minus 1/3 j plus 2/3 k.